In question 21a, we're asked what is meant by a vector quantity with an example. Well, a vector quantity has magnitude and direction. And an example would be force. 21b, we have a toy locomotive on a circular track of radius 0.60 meters. At t equals 0, the locomotive is at point A at the bottom. It travels at a constant speed, taking 20 seconds to travel completely around the track. For part 1, we want the speed. Well, speed is distance over time. The distance is the circumference of the circle, 2 pi r, and the time was 20 seconds. So we can then put in, it is 2 times pi times 0.60 over 20, which comes out at 0.19 meters per second. In part 2, we're asked to explain the shape of the graph shown in figure 21.2. Well, this gives displacement against time, and the displacement is the distance of the locomotive from A, so it will be symmetrical about the midpoint of 10 seconds. It goes back to 0 at 20 seconds as the locomotive returns to A, and at 10 seconds the locomotive will be 1.2 meters, or the diameter of its track, away from A. In C, we have an object with a 5 Newton force acting in this direction and a 7 Newton force acting in this direction. The angle between them is 40 degrees, and we're asked to find the acceleration, which will depend on the resultant. We're told the mass of the object is 0.320 kilograms, 320 grams. Okay, for this we can use the cosine rule, where c squared is equal to a squared plus b squared minus 2ab cos c. This is c, this is side c. We can call this a, and we can call this b, and a I said was 5 newtons and b is 7 newtons. So then c squared is equal to 5 squared plus 7 squared minus 2 times 5 times 7 times cos 40 degrees. This gives c squared as 20.4, so c is equal to 4.5 newtons. Then we can do acceleration is force over mass, which is 4.5 over 0.320, which comes out at 14.1 meters per second squared.